Okay, in this section here in calculus, we're talking about limits, and we're solving limits numerically. But let's say we're given a function f of x, 4 minus square root of x over x minus 16, and let's say that I want to evaluate it when x is 16. So I take 16, I plug it in for x, and we end up getting 0 over 0. So this down here is actually a graph of our function f of x, and here's 16 on the x-axis, and we go down, and I've got a red dot here where we would say there's a y value associated with 16. However, we're getting it's undefined here, and what that means is there's a hole in the graph. So there's a hole right here where this red dot is located. But we've got this concept called the limit, and the limit's going to actually tell us where this hole actually is. So if I were to pick a number that's just slightly larger than 16, like 16.1, and go down, there would be a y value associated with it. If I plug 16.1 into this right here, we would get actually some number out. And if I went to the left of 16, like 15.99 for example, and plugged that in, 15.99 into here, we would also get that some number out, and that number would be close to whatever 16.1 was. It would it would be fairly close to each other. And I'm using this word close kind of loosely. But we're going to use the limit to actually tell where this actually is, this hole is. Except in this section, this is all about doing it numerically. And let's scroll on down and take a look at what I mean by that. Okay, so this is our setup right here. And I'm claiming that it's equal to -1/8. That's where the hole is actually at. But remember, when we actually evaluated and took 16 and plugged it directly into the function, we get 0 over 0. So we've got to figure out where is the hole. And I'm claiming this is equal to -1 over 8. Now what we're going to do here is we're going to do this what's called numerically. And I'm going to pick a number, for example, we'll come way out here to 16.1. We take 16.1 and we plug it into the function here, plugging this in, and you should get -0.12481. Now we're going to get a little closer to 16 from the right hand side, and when we plug 16.01 into our function here, right, we end up getting -0.12498. So you should try plugging this into a calculator, right, and seeing what you get, and you should get something like this. Now I think I do some rounding here. I mean, we can only go out so far, right, and I think I'm rounding to 5 decimal places. But as you can see here, coming in from the right hand side, we're getting close to this exact value here, which is the -1 over 8, but I write it in decimal form here, -0.125. Okay, so you can see here that this number is getting closer to the 0.125. Now I could have done another one, and that's 16.001, and you would see that we would be converging closer and closer to this 0.125, but I just went to 0.01. Now that's coming in from the right hand side and coming in from the left hand side, so I'm out here at 15.9, plug that in, okay, and we get -0.12520, and then we get a little bit closer to 16 from the right hand side. I'm sorry, we're coming in from the left hand side of 16, and we plug 15.99 in for x, and we get -0.12502. Now as you can see here that this means that we're getting closer to this 0.125. Now I could have went 15.999, right, and it would just be showing us that we're getting closer and closer to the 0.125. Okay, so that's the difference between evaluating the limit and evaluating the function at the point.